Okay guys, so we're going to start chapter 11 for test 3. It's all about algebra basics. So the first thing that we're going to look at is solving equations. But before we do that, we need to define what is an equation. So an equation is a number sentence with an equal sign. It's important to know this because whenever we're talking about equations, we're going to talk a lot about the sides of an equation, and the sides just refer to the things on either side of the equal sign. So the equal sign is kind of the dividing point for an equation. The first one we're going to look at is solving equations using the addition principle. These are simple equations, and you can probably figure out the answers to them without having to do anything, but we need to understand these principles and know how to use them for when our equations get a little bit bigger. So the first thing I'm going to ask you is, what's the opposite of addition? And you're probably thinking, well, that's easy. It's subtraction. Hopefully that's what you thought anyway. So if the opposite of addition is subtraction, what's the opposite of subtraction? Addition. So these are important because you need to know the opposites, because we're going to do a lot of opposite operations. So whenever you're looking at an equation, first thing you need to do is determine which operation is connected to the variable in the equation, and then perform the opposite operation. So if you look at this equation, x plus 4 equals 7, what is happening on the side with the variable? We're adding 4. So in order to solve it, we need to subtract 4. But whatever we do to one side, we have to do to the other side. So we're going to subtract 4 on the x side and on the number side. What happens with these two 4s? If you have a plus 4 and a minus 4, you get a 0. So that should give us then x equals, and then 7 minus 4 is 3. So the same thing over here. We have x minus 3 equals 9. We look on the side with the variable, we have x minus 3, so we're subtracting. So in order to solve it, we're going to do the opposite operation. So we're going to do plus 3. And remember, what you do to one side, you do to the other. So we have plus 3 plus 3. So we would end up with x equals, because negative 3 plus 3 is a 0, so we have x equals 9 plus 3 is 12. Okay, we're going to look at a few examples. This is page 459. First thing it's going to ask you is to determine if a number is a solution to an equation. That just means whenever you, they give you a number, like 14 here. They want you to substitute it in place of x and decide if that makes a true sentence. So we would have 14 plus 19. Oops. Does that equal 43? So we just need to add 14 plus 19 and determine if that equals 43. So 9, 10, 11, 12, 13, so that's 33 equals 43. Is that a true statement? Hopefully you realize that that is not a true statement, because 33 and 43 are not the same. So 14 is not a solution. Okay, so let's try another one. What about number 8? So we're going to take our 24 this time and plug it in for x. So we have 24 divided by 6. Does that equal to 4? So 24 divided by 6. How many times will 6 go into 24? 4 times. So we end up with 4 equals 4. And yes, so then 24 is a solution because 4 equals 4 is a true statement. Okay, so then the other part of this section is just using the addition principle to actually come up with a solution. So at this point, for like number 11, you have x plus 7 equals 9. We want to know what number for x makes this sentence true. So again, we're going to use our principle. So on the side with the variable, we have a plus 7. So to solve it, we're going to do minus 7. We do minus 7 to the other side of the equal sign as well. So we have these make a big 0, so we end up with just x equals 9 minus 7 is 2. So we want to check this to see if it makes a true statement. So we're going to plug it back in. 2 plus 7 equals 9. Is that true? And yes, it is. So we know that 2 is our solution. Okay, what about number 14? We have negative 10 plus y equals 3. Well, on the side with the variable, you may think, oh, well, we're adding. We are, but we're adding a negative 10. So what's the opposite of adding a negative 10? Adding a positive 10. So we're going to add 10 to both sides. Notice that every time I do this, I never do anything with the y, or the variable, because that's what I'm looking for. I want to know what number goes in place of this variable. So I'm not going to do anything with it. So again, 10 minus 10, that's a big 0. So I have y equals 3 plus 10 is 13. Again, we want to check this. So we have negative 10 plus 13. Does that equal to 3? And these are opposite signs, so that means we are subtracting. So 13 minus 10 is 3, and we take the sign of the larger, so the 13 is positive. Our answer is positive, and that is true. So that's our solution, y equals 13. Let's do one with fraction just to make sure we remember what to do with fractions. So we have r minus 1/2 equals 3/10. So on the side with the variable, I'm subtracting 1/2. So I need to add 1/2 to both sides. So again, the negative 1/2 and the positive 1/2 give me a 0, but I still have my r. And then I have 3/10 plus 1/2. Well, I need to make the bottoms match, so I can change my 2 to a 10 by multiplying by 5. So 2 times 5 is 10. 5 times 1 is 5. So now I can add 3/10 plus 5/10. So I'm just going to add my numerators. 3 plus 5 is 8 over 10. And that is reducible. So I get r is equal to 4 over 5. So this is 11.1, so this is going to be your homework for Wednesday night.